Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So I have 5 to the power of x plus 5 to the power of x is equal to 7. Now, 5 to the power of x here, because this is here twice, I'm simply going to factor this out from my left-hand side. So now I have 5 to the power of x times, now 5 to the power of x divided by 5 to the power of x, well, anything divided by itself is simply 1. So I have 1 plus, again, 5 to the power of x divided by 5 to the power of x is 1. So now I have 5 to the power of x times 1 plus 1 is equal to 7. Now we're going to simplify what's in the parentheses. 1 plus 1 is equal to 2. So I have 5 to the power of x times 2 is equal to 7. Now we want to go ahead and isolate 5 to the power of x, so I'm going to divide both sides by 2 so I can move 2 to my right hand side. So then these two would cancel out, and I would have 5 to the power of x is equal to 7 over 2. Now what I'm going to do is I'm going to take the log on both sides. So now I have log 5 to the power of x is equal to log 7 over 2. Now, an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. And so this would be equal to b times log a. And the reason this property is so important is because let's say we have 7 to the power of x is equal to 9, right? So I'll first start by taking the log on both sides. So I have log 7 to the power of x is equal to log 9. And then I can actually move this x to the front by using this property. So then I have x times log 7 is equal to log 9. And then I would divide both sides by log 7 to find the value of x, because now x isn't an exponent, it's a real number. So that's why I'm using this property on 5 to the power of x is equal to 7 over 2. So I'll first take the log on both sides. Log 5 to the power of x is equal to log 7 over 2. And then I can move my exponent here to the front. So now I have x times log 5 is equal to log 7 over 2. Now, if I have something in the form log a over b, another important property of logarithms, this is equal to log a minus log b. And also, if I had something in the form log a times b, this would equal log a plus log b. So in this case, we aren't going to use the second property. We are going to only use the first property, which is log a minus log b. So in this case, a would equal 7 and b would equal 2. So now I have x times log 5 is equal to log 7 minus log 2. All right, so now to solve this problem, what I'm going to do is I'm going to first start by isolating x, because we obviously want to isolate x to find the value of x. So now if I divide both sides by log 5, these two cancel out, and I will be left with x is equal to log 7 minus log 2 over log 5. Now, to actually continue with this problem, I have to actually plug in, or I have to use a calculator to find the values of log 7, log 2, and log 5. So now if I plug these values into my calculator, I get log 7. This is equal to approximately 0.8451. Now log 2, this is equal to approximately 0.203. Oh, sorry, that's not right. 0.3010. And finally, we have log 5. And this is equal to 0.6990. All right, so now all that's left is to plug these values into our original equation. So I have x is equal to log 7, which is 0.8451, minus log 2, which is 0.3010, divided by log 5, which is 0.6990. Now 0.8451 minus 0.3010, that is going to equal 0.5441. And we still have this divided by 0.6990. And finally, 0.5441 divided by 0.6990, that is approximately equal to 0.778. Now, to check, our original equation was 5 to the power of x plus 5 to the power of x is equal to 7. Now we have x is equal to 0.778. So now if I substitute an x, or 0.778 for x, I get 5 to the power of 0.778 plus 5 to the power of 0.778 is equal to 7. Now, 5 to the power of 0.778 is approximately equal to 3.5 plus, again, 3.5 is equal to 7. Now 3.5 plus 3.5 is 7, so I have 7 equals 7. Because this is right, our solution is right. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 1 divided by x is equal to 27 to the power of x. Now, what I'm first going to do is I'm going to take the power of 1 over x on both sides. So now we have 1 over x to the power of 1 over x is equal to 27 to the power of x to the power of 1 over x. Now, if we have something in the form a to the power of m to the power of n, this is simply equal to a to the power of m times n. So as you can see here, we have 27 to the power of x to the power of 1 over x. This would equal 27 to the power of x times 1 over x. When for x times 1 over x, these x's simply cancel out, and we are simply left with 1. So this would be 1 over x to the power of 1 over x is equal to 27 to the power of 1. Now 27, this is the same thing as 3 to the power of 3. So now we have 1 over x to the power of 1 over x is equal to 3 to the power of 3. Now, if we have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So as you can see here, 1 over x is a in this case, and 3 is b, meaning 1 over x is equal to 3. Now, if I multiply both sides by x, these two cancel out, and I get 1 is equal to 3x. Now, if I divide by both sides by 3, these two cancel out, and I get x is equal to 1 over 3. So this is our answer. Now, to check, let's plug in x in this equation. So now we have 1 over 3 is equal to 27 to the power of 1 over 3. Now, 27 to the power of 1 over 3 is the same thing as the cube root of 27. And the cube root of 27 is 3. So now we have 3 is equal to, now 1 over 3 is the same thing as 3. So 3 equals 3, because this is right, we know that our solution is right.